The harbor of Baltimore, Maryland is a bustling artery of American commerce. For nearly half a century, the Francis Scott Key Bridge stood as its sentinel. Carrying over 34,000 vehicles a day, the massive 9,000-foot steel structure was a triumph of 1970s engineering. But on the cold, quiet morning of March 26, 2024, a catastrophic convergence of a microscopic mechanical failure and decades-old structural vulnerabilities would bring this giant crashing into the Patapsco River in just a matter of seconds. Our journey begins late in the evening of March 25th. At the Seagirt Marine Terminal, cargo operations aboard the Singapore-flagged container ship Dolly have just concluded. The vessel is immense, 984 feet long, displacing over 112,000 metric tons and stacked high with 4,679 shipping containers. Her destination is Colombo, Sri Lanka, a grueling 27-day transit. As the clock ticks past midnight into March 26th, two mandatory Maryland state pilots board the vessel to guide the behemoth through the restricted, shallow waters of the harbor. On the ship's bridge, the master, second mate, and helmsman take their stations. Down below, deep within the thrumming hull, the engineering crew completes their departure checklists. Two of the ship's four massive diesel generators, generators 3 and 4, are online, supplying 6,600 volts of high-voltage electricity to the main bus. Generator 2 rests in standby. The steering pumps are tested and logged as satisfactory. To all parameters measured by the human eye, the ship is in perfect working order. At 0036, the Dolly casts off. Two powerful tugboats assist her into the main channel. By 0108, the ship is steady in the Fort McHenry Channel. Following standard protocol, the tugboats unhook their lines and disappear into the dark. The Dolly is now traveling under her own immense momentum, ordering slow ahead to reach a speed of just under 9 knots. Ahead of her, resting exactly where the channel aligns, lies the central span of the Francis Scott Key Bridge. At exactly 25 minutes past 1 in the morning, the unthinkable happens. Without warning, the Dolly suffers a total, low-voltage blackout. What the crew did not know was that a silent, invisible failure had been waiting to strike inside the high-voltage switchboard. A tiny signal wire, known simply as Wire 1, had slipped from its terminal block. During construction, a small piece of heat-shrinkable plastic labeling tape had been improperly installed, covering the wire's ferrule. This minor physical impediment prevented the wire from being securely gripped. Over time, vibrations caused the wire to wiggle free. When Wire 1 disconnected, a critical circuit breaker instantly dripped open, cutting off power to the step-down transformers. In a fraction of a second, the low-voltage bus went dead. The consequences are immediate and terrifying. The ship's lights fail, plunging the crew into darkness. More critically, power is lost to the steering gear hydraulic pumps and the main engine cooling pumps. Just 8 seconds after the blackout, because of a loss of cooling water pressure, the Dolly's massive main engine automatically executes an emergency shutdown. The ship has lost all propulsion, and her massive rudder is locked dead center. She is an unguided 112,000-ton projectile drifting just 3,200 feet from the Key Bridge. On the pitch-black bridge, the pilot realizes the ship is no longer holding her course. The Dolly is swinging to starboard, directly towards Pier 17, the southern concrete support holding up the main span. Down in the engine room, the ship's electrician works frantically. 58 seconds into the blackout, he manages to manually close the transformer breakers, restoring low-voltage power. The lights flicker back on, and steering pumps 1 and 2 scream back to life. The underlying crisis is far from over. Because the ship's breakers had been left in manual mode rather than automatic, 48 precious seconds were lost just trying to get the power back. Worse still, the emergency diesel generator, legally required to start within 45 seconds, takes 70 seconds to connect because a faulty mechanical damper delay keeps it from firing. At 0127, a secondary disaster strikes. The generators require a specific pump to stay pressurized with fuel, the flushing pump. But this pump never designed to restart automatically after a power failure. As the crew tries to stabilize the ship, generators 3 and 4 choke out from a lack of fuel pressure. The ship plunges into a second, total blackout. The pilot orders the helmsman hard over to port and calls for the port anchor to be dropped in a desperate bid to drag the ship away from the pier. But it is too late. The massive vessel has crossed out of the navigation channel and enters the shallow mud. Her momentum is unstoppable. While the nightmare unfolded on the water, an ordinary night was taking place on the bridge deck above. A 7-person road maintenance crew and 1 inspector were on break, repairing potholes in the quiet morning hours. They had no idea that a massive container ship was bearing down on them. At 1:25, right after the first blackout, the pilot made an urgent phone call to the shoreside dispatcher, demanding that local authorities immediately close the bridge. It was a call that saved dozens of lives. Police units stationed at both ends of the bridge acted instantly, pulling their cars across the lanes and stopping traffic. The bridge was successfully cleared of moving traffic just 48 seconds before impact. But in the chaos, there was no emergency communication system to warn the workers already on the span. At 1:29:09, the Dolly strikes Pier 17 at a speed of 6.4 knots. The impact force was calculated to be over 4 times the lateral capacity of the concrete pier. The support crumbles instantly. 13 seconds later, the entire central through truss of the Francis Scott Key Bridge collapses into the Patapsco River, crushing the bow of the ship under thousands of twisted steel. The immediate rescue operation was massive, involving the U.S. Coast Guard, local fire departments, and dive teams. Of the 8 men working on the bridge, the inspector managed to run to safety, and 1 highway worker miraculously survived after swimming to floating debris. Tragically, the remaining 6 highway workers lost their lives, trapped inside their vehicles as they plunged into the freezing water. The subsequent investigation by the National Transportation Safety Board exposed a chain of systemic failures. Beyond the improperly installed wire label that initiated the blackout, the NTSB revealed that the bridge itself was wildly unprotected. Had the state conducted a proper modern vulnerability assessment, they would have known the Key Bridge faced a risk of catastrophic collapse 30 times higher than acceptable modern design thresholds. Moreover, the lack of automated backup power systems on large single-engine cargo ships left the crew entirely defenseless in tight waterways. The collapse of the Key Bridge was a stark reminder of the fragile thread holding our modern infrastructure together. A single millimeter-thick piece of plastic tape placed incorrectly on a wire years prior caused a multi-billion-dollar catastrophe and cost 6 men their lives. As global shipping vessels continue to grow larger, the lessons of the Dolly stand as a grim warning written in the ruins of the Patapsco River.